Good morning, everyone. I am Lauren, and today me, Christine, Ashton, and Jacyie are going to go over a math and science integrated lesson. It is so important to integrate your different subjects because it allows you to connect concepts with other subjects. This also allows you to expand your knowledge on what you are learning throughout the lesson. So it is so cool to get to pull math and science together whenever you are doing one lesson, whenever you are really learning and focusing on two different subjects. So now let's go over the different TEKs we are going to be discussing throughout this mini lesson. So the math TEKs that we are going to talk about is model and solve one variable, one-step equations, and inequalities that represent problems. The science TEKs that we're going to be focusing on are calculating average speed using distance and time measurements, and to measure and graph changes in motion.
Hello, my name is Christine and I'm going to go over the math lesson with you. So today we are going to learn how to rearrange equations so that we can get x by itself. All right, so the first step, like I said, is to get x by itself. So how do we do that? Well, in our equation, 6x equals 30. We're saying 6 times x is equal to 30, but we don't know what x is. So what we have to do is somehow rearrange this so that the 6 is no longer with the x, and we have the statement x equals some number. So let's do that. So in this example, we are going to divide our 6, all right, our 6 divided by 6. All right, and what this does is it cancels the 6 out to 1. All right, so we just have 1 times x. But whatever we do with the left side of the equation, we have to do with the right side in order to keep the equation equal, all right? Remember, equation equal, all right? So if we divide by 6 over here, we need to divide by 6 on the right side. So 30 divided by 6 is equal to 5, all right? So we can actually check this answer. What is 6 times 5? Well, it's 30. So our statement is correct. All right, here's our second example. It's a little bit more complicated, but we can work through this together and find the answer as well. So here we have 5 is equal to x divided by 5. So some number divided by 5 is 5. So how do we do this? Well, let's remember our reciprocals. All right, what's 1 divided by 5 times 5 divided by 1? Well, it's equal to 5 over 5, which is 1 again. So for this example, we have to multiply x divided by 5 times 5 over 1. And 5 over 1 is our reciprocal, all right? Whenever we do this, the 5 in the numerator and the 5 in the denominator cancel out, and they actually give us 1, which you can see in my third line of equations. All right, and what does that leave us with? It leaves us with x is equal to 5 times 5. All right, so let me backtrack a little bit. I forgot. If we multiply by 5 over here, we have to multiply by 5 on the left-hand side of the equation too. All right, so that's where that extra 5 over 1 came from. All right, so we canceled out this 5 over 5, all right? We made it 1. All right, so now our new equation is x equals 5 times 5, all right? And 5 times 5, as you know, is 25. So that is our second example.
Alrighty, and now for our science lesson, we are going to talk all about speed. So, you may be wondering, what is speed? Well, speed is how fast or slow an object moves in a certain amount of time for a certain distance. And so our formula for speed is right down here, and it is speed equals distance divided by time. So in order to use this formula correctly, we need to understand what distance is exactly and what time is. So Distance is how far an object moves, and time is how long it takes an object to get somewhere. So, to reiterate, speed equals distance divided by time. Later in this lesson, we are going to use this speed formula, so pay close attention and try and remember that speed equals distance divided by time. And now we are going to watch a short video over how to calculate speed. And in this video, you will see real-world examples applied. So you can think about how you can calculate speed in your daily life. Alrighty, class. So I hope that video made the formula for speed a little bit more clear.
Now that you know the materials that you will use for this lesson, here's how it works. You and your partner are going to either run, walk, or jog 20 meters. The person that isn't running is going to time the person that is running. Once you finish the 20 meters, stop the timer and calculate your speed by using the speed formula. You and your partner are then going to switch places. After that, you'll find the time of your classmates. So once you get back in the classroom, you and a few of your classmates are going to exchange 2 of your pieces of data, either your speed or your distance. With your new data, you will then find the missing variable with your new algebra problem-solving skills. Some questions to consider. 1. Explain how your speed, distance, and time are related. If you alter the distance you run, will that necessarily alter your speed? And what must happen to the time? Second question. Speed is considered a rate because you divide distance over time. What are some other rates you see in life? And last question. Draw the tortoises and the hare's speed graphs at the beginning of the race. How would you expect their graphs to compare?
Alrighty. And so lastly, we need to focus on how are these 2 skills integrated? How is this math and how is this science skill integrated? Throughout this lesson, you calculated speed with algebra skills. You took distance measurements and time measurements to calculate your speed because, as we know now, speed equals distance divided by time.
All right, with this understanding of speed and how it is a proportion, let's look at a practice problem that you could have. So let's say Charlie ran for 20 seconds at a speed of 13 meters per second. How many meters did Charlie run? Well, we're going to go to the next slide and look at this problem in depth. So here we have our rate, which is 13 meters per second, and it's equal to meters divided by time. And we filled in time, all right? So he took 20 seconds to produce a rate of that much. Well, how do we remove or cancel out the 20 in the denominator so that we can have our equation equals to m? Well, it's the same idea of multiplying by a reciprocal, right? So here, this is represented as 1 over 20, and we just removed the m for simplicity, all right? So there's an imaginary 1 by this m, and that's what's over here. So 1 divided by 20, is equal to, or excuse me, not equal, but 1 divided by 20 times 20 over 1 is equal to 1, because if you have 20 pieces of chocolate and you give them to 20 people, then each person gets 1 piece of chocolate. All right, so what if we multiply our speed or our rate by 20? Well, on the right-hand side of the equation, we would have 20 over 20, which is equal to 1. It cancels out. But whatever we do to the right-hand side, the left-hand side has to have the same change, all right, to keep the equations equal. We're never trading anything out. We are just rearranging numbers. So we have to multiply 13 by 20, all right? You see how these two blue fractions are equal, all right? One's on the right, one's on the left. Well, 20 times 13 is 260. So how many meters did Charlie run? He ran 260 meters. Wow, because 260 is equal to m. All right, we can even check this. So let's plug it back in to our original equation and see if m is equal to 260 if we get our rate of 13 meters per second. All right, so 260 divided by 20 is in fact 13 meters. So our answer is correct. Thank you for listening to our lesson. I hope you found it enlightening and you have a new understanding of how you can integrate math and science, even something as simple as algebra and speed. So just to reiterate what we talked about in this lesson, we talked about solving algebra equations just with abstract numbers where x equals some number. And this was specifically with multiplication or division. All right, and then we looked at calculating speed and what that looks like and the rate for it. All right, and then we applied our algebra equation skills to the speed equation and saw how we could find different variables based on our understanding. Once again, thank you so much, and I hope you have an excellent day.